Algebra 2, Unit 5, Lesson 4, Two-Variable Inequalities. In this lesson, we want to solve linear inequalities and interpret for real-world situation, and we also want to solve absolute value and quadratic inequalities. For linear inequalities, it's an inequality in two variables whose solution make up a region of the coordinate plane that's bounded by a line. To graph, you're going to graph the boundary line, and then you're going to graph either the plane above it or below it. If you want to show that the line is included, meaning there was an equal in the equality, you're going to use a solid line. If there's no equal in the inequality, you'll end up using a dashed line, and then you're going to shade either above or below. If it's written like this, less than will mean it will be below, bigger than means it will be above. If you can't tell or you don't have it written that way, you can pick any test point that's not on the boundary line. If 0, 0 is not on the line, that's the easiest thing to use. If it makes the inequality true, you would shade the side with your test point. If it makes the inequality false, you would shade the side without your test point in it. So if we want to graph the inequality, 6x minus 2y is less than 12, and then we're going to name three solutions. Because this is in standard form, we can find the intercepts. If we put y equals 0, we get 6x equals 12, so that would be x equals 2. If we put x equals 0, we get minus 2y is 12, so y would be minus 6. And then we can use the rise and the run to find another point, graph our line. We put a dashed line here because there's no equal in the equality, meaning this line itself, they are not solutions. And now we have to shade one way or the other. Because this is not written in y equals mx plus b form, we can put any test point. 0, 0 is not in there, but if we put 0 and 0, is 0 less than 12? Yes, it is. That means this point makes it true, meaning every point on this side of the line makes it true. So we have shaded that entire region. If this had made it false, we would have shaded every point on the opposite side. So three solutions are any point in the shaded region. I happen to pick 0, 0, 1, 6, and minus 5, minus 4, but any point in that shaded region is a solution to that inequality. You can do this on your graphing calculator, but it's generally not very helpful because you have to know whether to shade above or below, and you can't tell whether the boundary line is included or not on your calculator, so you have to know what to use in order to graph. You also have to rewrite the equations in slope-intercept form in order to use that. But what you do is, if you really wanted to check your work and you actually had some feeling for what you do, in the y equals, you have to go over and change this symbol to something different. So when you hit this, you hit enter, you highlight this part of it, and you can change the color, or you can change this to something different. You can toggle through there. It will go through different things that will shade one way or the other. So that's how you would change it, but it's, as I said, it's really not very useful. Absolute value inequality is when you have an absolute value equation and then you're either going to shade above the absolute value or below it. Quadratic inequality is when you have a quadratic boundary with an x squared, and again, you're going to shade either within the boundary or outside of it. You have to have y alone on a side by itself, and then similarly, you're going to use either a solid or a dashed line, if you like, or boundary, and then shade above or below, or you can use a test point. So this says y minus 3 is less than or equal to the absolute value of x minus 2. We would take the 3 on the other side. So we need to graph y is less than or equal to the absolute value of x minus 2 plus 3. We know that this shifts 2 to the right and up 3. So it would shift 2 to the right and up 3. And then we have a slope of 1 on this side and a slope of minus 1 on this side. And now we could pick a test point, or it says y is less than that. That means we know it has to be below. Or you could pick a test point if you put 0, 0. If you put 0 in on this side, that would be a minus 3. And on this side, you would get a positive 2. Minus 3 is less than 2, so you would shade the part including 0, 0. Again, possible solutions are any point in that shaded region. Now you could also give boundary points because that equal means that the line itself is included. Here we have a quadratic inequality. It says y plus 5 is bigger than 2 times x minus 2 squared. We would first have to take that 5 to the other side to get this. And now we know that this shifts this 2 to the right and 5 down. That will shift the vertex. Again, the vertex, because it starts off at 0, 0 for the main function, is not affected by stretches or shrinks or by reflections across any axis. So we move to 2 to the right and 5 down, and then this 2 would mean, well, normally we went over 1 and up 1. We'll now go over 1 and stretch that up to 2. Normally you would go over 2 and up 4. That 4 gets doubled to 8, and that will give you this equation. And now where the boundary is not included because it's strictly bigger than, so we would not include this. Bigger than would mean the parts above that function. So if you take any point on the function, you would want to shade the part above that. Or if you would rather use a test point, you can pick something. The 0, 0 is not on the boundary, so you could again say 5, is that bigger than 8? And it's not, so the 0, 0 would not be included the solution, and that would leave the inside part. As a word problem example, we have a student council event that's selling mugs for $5 each and t-shirts for $10 each. Their goal is to raise at least $500. How many of each do they need to sell? Give at least 3 solutions. If they sold 50 mugs, how many t-shirts would they have to sell to reach their goal? Relate this to your graph. Like always, we need to define our variables. X is the number of mugs sold and Y is the number of t-shirts sold. You should label those things on your graph. Inequality is 5x, because what we're going to get is 5 from each mug and 10 from each shirt. So this would be what we get from selling those, 5x plus 10y, and we want to raise at least $500. This is in standard form, so if we put y equals 0, we get x is 100, and if we put x equal to 0, we get y is 50. So that would be this line according to my scale. And then 0, 0 is not a solution, so we would not shade this part, but the other part. Possible solutions are anything in the shaded region. You might want to know, like, for the minimum values, what you would have to sell to get that. So if you had 50 mugs and 35 t-shirts, that would get you $600. 20 mugs and 70 t-shirts up here would get you $800. 80 mugs and 50 t-shirts, which is in here, would get you $900. But if X is 50, what's the least you would have to sell? The least you would have to sell would be 25 t-shirts, which would be this line here. We would go to the line, and the least thing is the part here. Everything else more than that would earn you more money.